Okay.
We're on the porch swing problem. It was on a paper with an A and a B problem.
This one.
I'm not going to teach anymore. Just review, try to nail down this this torque type problems. Let me see if I have a couple more to do. If we can go through them quickly. If not, we'll save it for another day. So everyone in video land, that's half the class. Now there's only 4 of us here. So, you remind them what we were working on Friday. Can you show them? Is that, I don't know if I have to come close. You can move the camera or whatever you have to do. We're working on problem A.
Okay.
All right.
Yep.
And I'll put a couple of these up in the absentee folder if you nearby, or someone can pick them up for you. All right. Would you look at what I have on the board and match it to the problem? Do I have all the information right?
I believe so.
I have not. So
it should be
you're-
0.5.
Very good. I did that on purpose. So. Just to get you. All right, so this is 0.5 meters. The girl is pulling. Remember, it wasn't drawn to scale. 0.5 meters from the right. 0.75. The guy is from the left,
And you
and
put
the
in their
actual
weights.
porch.
Their weights.
Pardon? Oh yeah. What is their weight?
The guy's 650 newtons and the girl's 490 newtons.
Thank you. All right. All right. I know we started on this on Friday. Let me catch us back up to where we were. Let's draw in the forces. So we'll go around the room. Emily, 1. What is one force that is in this picture?
The force of the boy on the seat.
The what?
The force of the boy on the swing.
The boy? All right,
Yes.
well, his weight downwards. I'll take that. All right,
Okay.
so we're going to do a collection of forces, and it's going to be the sum of the forces equals ma. But the force, I mean, the acceleration is not, there is no acceleration, so the right side zeroes out. The porch swing is still. It's in equilibrium, 0. All right, what's another force, Emily? 2?
The force of the swing on the chain.
All right, I'm not talking about interactive pairs, but there is a force from the chain, right? And do you remember what that's called when we have forces that are lines or chains or strings?
That's what we did.
What's that kind of force called? Zach, what's that force called? Tension. All right, did we call this one tension 1 or 2?
We called it 2.
All right. All right, so then there's another force here. So Emily, 3. Is there another force we can draw in?
The force of the girl.
All right, yeah, the force of the girl creates the weight of the girl creates a force. So, and one more, Zach, what's the other?
The force of the swing down.
All right, the swing, and we decided that we would go from its center. That's where we're going to mark. That's the weight of the swing, right from the center of it. All right, so let's gather all our forces then. The sum of the forces, I'm going to add them all up. So we have tension 2 upwards, tension 1 upwards, the force of the boy downwards, the force of the girl downwards, and the force of the swing. To check our work, I think we got that far.
Yeah,
Did we-
except
did
T1 and T2 were switched on mine, but maybe I read it wrong.
What's that? T1 and T2?
Like T1 and T2 were switched. Like T1 should just be by itself, and T2 should have the 650.
Oh, so I think we solved it, I think. Let me see. Point to what you're saying.
Like I had T1 plus T2 minus 650, and you have T2 plus T1.
Yeah, that doesn't matter. Either way.
Oh, it doesn't?
Right, you're talking about these two are switched?
Yeah, like
Yeah.
the T2 is with the 650 instead of.
Yeah, it's not in any order.
Yeah,
These
fine.
is just the sum of all the forces, and so we can mix them
Okay.
all up. They're not
Okay.
they're not associated with one another. All right. Any other questions? All right. Did we get to the torques?
I think.
Some of the torques is also MA, but again, there's no rotational motion at all either. So we are in rotational equilibrium. So the torques add up to 0 as well.
There we
So
go.
Did we get that far?
Yeah,
All right.
650
I think I'm
times-
catching up now. All right, so every single force will create a torque. Where did we decide to rotate this around? We had to pick a rotation point.
Right
Oh.
at the T2.
This one?
Like right,
All right.
yeah.
All right, so that's going to be
So
our
that goes
rotational
positive.
point. You get to pick it. It's easier to pick it where there is actually a force, because it's this little zero out and it's a little less work. But you can pick the rotational point anywhere and it will always work. So this is an easier spot. This would have been an easier spot. All right, so this T2 creates a torque, but I'm going to say, remember torque is force perpendicular times a distance from the rotational axis. So T2 is creating a torque, and it is, the R however is 0, because this force is exactly on the rotational axis, so this part's going to be 0. So that whole first torque that I'm talking about here is 0, so I'm not going to worry with it. Let's go to the next torque. Create it, I'll just go across. We have a force, I'm looking for all the pink arrows to create torques. So Emily 2, we have what torque, what two numbers will multiply together at this point to give us this torque? And if this is the rotational spot, where, in which direction? Is it a positive torque or negative?
It's positive.
All right, because
Because it's
here's the
going
rotation,
clockwise.
it's going to go like that. I'm looking at the clock. It matches, so I'm going to get a +1. And what two numbers?
650 and then 0.75.
All right. All right, Zach, do the torque from the actual swing itself.
150 times 0.85.
All right, because 0.35, is that what you said?
0.85.
85 is half of that.
Mhm.
All right. Emily 3, this torque, this rotational, but
490
mhm.
times 1.2.
All right, is if the whole swing is 1.7 and she's sitting 0.5 from this side, how far is she from this side? Very good. And this is a T1, Emily 1. How far? What is the force on this torque? This tension, and what is its distance from the rotation?
Wait, say it again. I don't.
We didn't do this.
Yeah, we didn't do this. We just
Okay.
had.
Right.
I think we ran out right
Yeah, we
there.
ran out of time.
Okay.
Yeah, I think this is the moment of truth.
Oh, okay. Say it again.
I need the torque created by tension, this force, tension 1. Tension 2 zeroed out,
Right.
but tension 1 will create a torque because it's a force perpendicular. It's going to go around like that. So is it
Okay.
positive or negative?
Negative.
Right, so we got that much. And we don't know the amount yet. It's
Yeah.
just T1. And what is its distance?
Point. Is it the 0.5? Is that what you're talking about?
Now, its distance from the rotational axis. So how far between my thumbs?
1.7.
1.7. And all that goes to 0. All right, tippy tap on the bottom, because what you can find T1 down here, because T2 disappeared because it was 0. Its distance from the rotational axis was 0, so I didn't write it up. Let me write it up. T2 times 0, just so I can feel better about it. All right, so multiply all this out, move T1 to the other side, divide, and you should have T1. Then you go back to the first equation on force, put in your T1, and solve for T2. So now it's just number crunching. Okay, those in video land, it's no use you watching us crunch numbers. So what I'm going to do is I'm going to put up the second problem, and at that time I'll show you the answer to the first problem. It's just math now, so enjoy. Could you turn it off, please?